In Chapter 6, we explore additional applications and techniques of integration. For example, we use the integral to determine the cost of manufacturing downhill skies as a function of the production level from the fixed cost and the marginal cost. You can see the problem in the section 2 of the chapter 6 we will discuss. We also use the integral to find the probabilities. This is very important area, and to calculate several quantities that are important in business and the economy, namely the total income and future value produced by a continuous income stream. You will learn customers, producer surplus, we will discuss in this chapter, and the Gini index of the income concentration. Actually, we have already discussed the Gini index. As you know, Gini index is a single number between 0 and 1 that measure the equality of the country's income distribution. At the beginning of the chapter 5, I said that integral is an inverse operation of the derivative. And first we learn antiderivative, then we learn chain rule. Chain rule was a reflection of the substitution rule, integration of substitution. But integration is a reflection of the chain rule. Chain rule for derivative. Okay, substitution for the integral. Substitution is a technique to calculate the integral. Now we talk about the integration by parts. So, as you know, we have a product rule. So what is the product rule? Let's recall. Derivative of the f times g of x is derivative of the f of x times g of x. Your textbook can be given in a different order, does not matter. Plus f of x times derivative of the g of x. Okay, we know this is the product rule. Product rule for derivative. So from here, we can obtain the following equation. What does not matter which one of the chosen, but you can choose the one of the right side of the summation. Okay, for example, let's choose that one. So f of x times derivative of the g of x equals derivative of the f of x times g of x minus g of x times f prime of x. Okay, so by integrating the equation in terms of the x, we obtain the following formula. Integral f of x, instead of the this notation, we can use the g prime, the f of f times g prime of x dx, okay, for the simplification, equals, here you can use summation rule. So derivative, integral of this derivative itself, so f of x times g of x minus integral of this one, okay. So this is integral. Maybe here, instead of the f prime, let's write the derivative of the, let's use the Lipschitz notation, because here I use the Lipschitz notation. Okay, now I will write the f prime instead of this notation. G of x, like this part, g of x times f prime of x dx. So this formula is known integration by parts techniques. Okay, so maybe I should emphasize something here. in the first integral, okay, to the right side of the equation, is f of x plus g of x plus constant term c. Instead of f of x times g of x, it should be written f of x times g of x plus c. But we will leave out the constant of integration for now, since we can add it after integrating this integral, second integral, to the right of the equation. Okay. So this equation or this formula is very important for us. Actually, if you cannot calculate this integral, we can, instead of this integral, we can calculate that integral. Okay, but this is not useful. So this equation can be transformed into a more convenient form by letting u equals f of x and v equals g of x. But from the left side of the equation, you cannot see the g of x directly. Okay, so from here, by saying f of x is u and g prime of dx equals dv, okay, we can obtain the following formula. So this formula, integral u times dv equals, now f of x is u, and from here g prime of dx dv implies, let's write the right side, g prime x dx equals dv implies, by integrating this equation, we obtain the integral of derivative of this function. So this is g of x, right hand side is v. Actually, from left side we can we should add the constant term c. Maybe you can say that v equals g of x plus c. That's right, v equals g of x plus c. But we don't write the constant term here because actually we define g of x as a v at the beginning, but to find the g of x equals v terms, we choose this term. Okay, I mean, first of all, we say f of x is u and g of x equals v. Okay, so from here, just make analyze. I said that dv equals g prime, not turn back here. So actually our starting point is that point. So this implies f prime x dx equals du from the first equation, and from second equation g prime x dx equals dv. So by using 4 of this equation, we can say that this is u, this is dv actually. Okay, not we turn back here, but in the future, first we find the g prime of dx as a dv, and we will calculate the g of x, but never we write the constant term c because of this reason. So f of x is u, g of x is v, so u times v minus integral g of x is v, f prime dx is du, so this is du. So we will use this formula instead of that formula. Okay, this formula can be very useful when the integral on the left side, this one, is difficult or impossible to integrate with standard formulas. If u and dv chosen with care, this is the curious part of the process. Okay, this choose is very important. If u and dv are chosen with care, then the integral on the right side may be easier to integrate than the one of the left. Okay. The formula provides us with another tool that is helpful in many but not all cases. We are able to easily check the result by differentiating to get the original integrand, a good habit to develop. This technique is very important. So because of this reason, I would like to look to following example. Okay, so let's analyze this example. Find x e to power x dx integral using integration by parts. Otherwise, you cannot calculate actually. So here we have two alternatives. Okay, let's divide first way and second way. The first way is to say x is u, e to power x dx is dv. This is dx, sorry. So here we say this x is u, e to power x dx is dv. Actually, when choosing dv, you should be careful. The factor in the dv, here e to power x, can be integrated easily. Otherwise, you cannot choose, okay? So, according to that, this one, let's choose. Let u be x and e to power x dx is dv. So, u to power u equals x implies du equals dx. Actually, we need the du from here, okay? Because of this reason, I calculated. So, by integrating both sides, okay, let's show that. In the future, I can write directly v equals integration e to power x dx, which is e to power x. V equals e to power x. So, this integral, our integral equals u times v, x times e to power x, minus integral v times e to power x times du, which is dx, du equals dx. So, easily, we can calculate this integral. So x times e to power x minus e to power x. Now we add the constant terms here, okay? So as a result, integral x to power e to power x dx equals x times e to power x minus e to power x plus c. This is clear in my opinion, and which is easy. But let's choose another alternative and make some observation. X e to power x dx, okay? So let's write this one in the following form, x e to power x x dx. So now e to power x is u, x e to power dx is dv. So let u equals e to power x and x times dx equals dv. There is no problem here. You can calculate integral of x easily. So from here, du equals e to power x dx. From here, v equals integral of the x dx, okay? So which is x squared over 2. So, the integral equals, this integral, u times v, e to power x times x squared over 2, okay? Minus integral v times du, x squared over 2, e to power x dx. As you see, to calculate this integral more difficult than that one, okay? It is more complex when comparing to this integral. So, this selection is not a good idea, okay? So, not easy. To calculate this integral is not easy. So, second alternative should be chosen instead of the, first alternative should be chosen instead of the second alternatives, okay? So your selection is very important as you see in this example. As a summary, let's say some things. Okay, for u dv equals u times v minus v times du formula. Okay. First, the product u dv must equal to original integrand. Okay. So the product u times dv, this product, okay, must equal the original integrand. In the previous example, u is x, dv is a to power x dx, so x times e to power x dx is the original integrand, okay? There is no term missing, okay? Secondly, it must be possible to integrate dv. Why? Actually, dv is a function of the x, dx. Okay, I mean that one. dv is dv interpreted in terms of the x. Okay, so by calculating left side integral of the left side, you can decide the v. First of all, you need the v. Okay, so because of this reason, it must be possible to integrate dv. Okay, I mean by using standard formulas or simple substitutions, easily you should be able to calculate the v from the dv. And the new integral, which is new one, v times du. The new integral v times du should not be more complicated than the original. Integral. What is the original integral? Left side of the equation, u dv. And the integral involving, this is considered as a suggestion, the integral, actually these three are common for all integration by parts techniques. The integral involving x to power p e to power ax, okay, we recommend to use this variables, this integration by parts formula, u equals x to power p and dv equals e to power x dx. Okay, here we try to calculate this integral, actually x to power p e to power x dx integral. And for integrals involving x to power p ln x to power q, try to use these substitutions. These are substitution, but we have two variables. Ln x is q, ln x to power q is u, and dv is x to power p dx. Okay, in this case we calculate this integral x to power p ln x to power q dx. In general, instead of this two case, I can give us some strategy to say the u. Okay, so in the integration by parts, as you see, we have learned when the production of the two functions are given, to us, then we apply the required formula. So the integral of the two functions are taken by the consideration. One of them is as a u, the other of them is as a dv. Okay. So to say or to prefer order of the this rule is based on some functions such as the inverse, trigonometric, etc. So we use the following strategy. From the isolate, by changing the first two letters, we have Liate rule. Okay, so this is the order of saying u. So first we compare the two product. Okay, we have a two product in the integrand. So if this is logarithmic function, if there's a logarithmic function, in the first order you choose logarithmic function as a u. If this is inverse function, logarithmic functions are, let's give the example, ln x, etc. For the inverse function, arc sin x, etc. or arc cosine x, etc. A represent the algebraic functions. Algebraic. So what is algebraic functions? X square plus 2x plus 1, etc. T represent the trigonometric functions. What is the examples? Cosine x, tangent x, etc. For example, a logarithm base 10x also logarithmic function. Here we can say arc tangent x as an inverse function, etc. And E represent the exponential function. Okay, so for example, e to power x, to the power x, etc. So according to this order, if you choose your u, generally it works. Of course, there are some exceptions, but as a suggestion you can consider. For example, let's turn back to here. X to power p. This is algebraic function. This is exponential function. So according to Liate, first there is no logarithmic, no inverse function. First algebraic function here we have, and we have the exponential function. So we should say x to power p is u. Let's turn back this example. Second one. This is algebraic function. This is logarithmic function. So first you saw the logarithmic function, okay, from the algebraic function. So you should say ln x to power q is a u. Okay. So if you prefer this order, it works well.